Sam Altman is spending sleepless nights because of this model, and Dario Amodei is also very upset with the benchmark score, because Microsoft did something unexpected from nowhere. Microsoft announced a new AI security system called M-, and what happened next caught a lot of people off guard. This system climbed to the top of a major cybersecurity benchmark and scored 88.45%. That number alone doesn't sound dramatic, but wait until you hear who it beat. Some of the strongest AI systems available today were tested in the same environment. One of them came from Anthropic, and another came from OpenAI. And these were not lightweight versions. These were some of their most advanced systems. That's where this gets interesting, because this might say something much bigger about where AI is going next. For the last few years, everyone has been thinking about AI progress in almost the same way. Train a larger model, add more data, add more computing power, make the model smarter, repeat. And to be fair, it worked. Each generation became stronger, each model became more capable. But Microsoft just demonstrated something that almost feels like cheating. Instead of asking, how do we build the smartest AI? They asked, what if one AI isn't the answer? What if many AIs working together can outperform a single supermodel? That question led to MDASH, short for Multimodal Agentic Scanning Harness. Think about building a house. You don't hire one person to do everything. You have an architect, electricians, plumbers, builders, inspectors. Everyone handles a specific job. Now imagine software security working the same way. Instead of one AI trying to inspect millions of lines of code, you create a team. One AI searches, one challenges, one verifies, one tests, one tries to prove the problem is real. That's basically what Microsoft built. Not one brain, a company of brains. And according to the benchmark results, that strategy worked. The benchmark they tested on is called cybergym. Its job is simple: give AI system software that contains known vulnerabilities, then see whether the AI can actually find those problems and reproduce them. The AI has to understand code, trace behavior, figure out weak points, and show that the weakness actually exists. That's difficult because software bugs aren't always obvious. Sometimes the mistake is buried across thousands of lines. Sometimes the cause is in one file, but the effect appears somewhere completely different. Humans miss these things all the time. That's why benchmarks like this matter. And here is the part people started talking about. Microsoft reached the top score, but they didn't do it using one secret supermodel. They openly said something important. A lot of the models inside M- were generally available. That's like entering a Formula One race, not by building the fastest engine, but by designing the smartest pit crew. Same car, better strategy, and strategy won. The people working on this came from serious security backgrounds. Several members were connected to teams known for autonomous cybersecurity research. Some had already worked on high-level offensive and defensive security systems before. Now, what exactly is M- doing behind the scenes? Because if one model isn't running the show, then who is? They actually make more than 100 AI agents work together without turning everything into chaos. If you put 100 people in one room and ask them to solve a problem, usually nothing gets done. Everyone talks, nobody agrees. But Microsoft designed M- differently. Instead of giving every AI equal control, they built a pipeline. M- works through 5 major stages. Stage 1, prepare. Before searching for vulnerabilities, the system first tries to understand the software. Imagine opening a massive textbook. You don't start memorizing page 1 immediately. You first look at chapters, headings, important sections. That's what the prepare stage does. M- reads source code, builds maps, creates indexes, looks at previous changes, studies how different components connect, and identifies areas that could become attack points. Basically, it tries to answer, if I were trying to break this software, where would I start? That preparation matters, because scanning random code blindly would take forever. Stage 2, scan. Now the search begins. This is where auditor agents start working. Their job is simple. Look for anything suspicious, anything unusual, anything that feels off. One agent may track memory, another may follow user input, another might inspect permissions, another might look for dangerous patterns. And these agents generate findings, not conclusions. Stage 3, validate. This might be the smartest part of the entire system. Instead of trusting the first answer, Microsoft introduced debate. Yes, actual debate. One group of AI agents makes a claim, another group tries to destroy that claim. Imagine one AI says, "This looks vulnerable." Another responds, no, because this condition blocks the attack. Then another says, that block only works in one case. Then another says, but what if this input changes? The agents argue, challenge assumptions, test logic, and slowly bad findings get eliminated. Good findings survive. This is surprisingly powerful because humans often trust first impressions. These agents don't. That's important because cybersecurity is messy. There isn't always one obvious answer. Sometimes the truth appears only after multiple viewpoints collide. Stage 4, deduct. Now imagine 40 agents all report the same issue. That sounds impressive, but it creates clutter. So M- compresses similar findings. If multiple agents discovered versions of the same problem, they get grouped together. That way, security teams don't receive hundreds of duplicate alerts. Only meaningful reports survive. Stage 5, prove. Now comes the hardest part. Can the bug actually happen? Because theory means nothing. If someone says there might be a vulnerability, you still need evidence. So another set of agents tries to trigger it. They generate inputs, run tests, execute scenarios, and attempt to reproduce the issue. If the system can actually activate the bug, confidence shoots up. Now it's no longer maybe. Now it becomes, this is real. What happens when you release this system on actual Windows code? And what M- found inside Windows became one of the most interesting parts of the entire announcement. The system discovered 16 vulnerabilities that ended up being prepared for security fixes. And 4 of those were considered critical. That is not a small demo. That's production software used by millions of people. Now Microsoft asked a harder question. If we go back in time, take old versions of Windows before security patches existed, would M- find those vulnerabilities again? Microsoft selected older versions of heavily reviewed Windows components. These weren't random files. These were systems that had already gone through professional security reviews. This time, the result was even stronger. M- achieved 100% recall. Every known case in that test was rediscovered. Here is the part that makes this bigger than a cybersecurity story. Because everything sounds exciting when you imagine defenders using it. Faster detection, safer software, less time for attackers, better protection. But technology almost never stays on one side. If defenders can do something, attackers eventually learn too. And that is the uncomfortable part. Because M- was not built using secret physics. It was not powered by impossible hardware. Microsoft openly described it as a system built around available models and engineering, which means attackers can also make their own versions fast. Now imagine both sides suddenly get teams of AI assistants. One side finds weaknesses faster, the other side patches faster, then attackers automate again, then defenders automate again. Everything accelerates. That is the future people are starting to imagine. Not humans versus AI, but AI helping humans on both sides. Microsoft's message was not, our AI is smarter. Their message was closer to, our system makes better use of intelligence. That difference matters. Because systems survive upgrades, models change, systems stay. When better models arrive, swap them in, keep everything else. And that could become extremely important over the next few years. Because frontier models are getting expensive, training stronger models requires enormous amounts of compute, energy, data, specialized talent. Only a small number of companies can play that game. But building better systems, that opens more doors. You may not need to own the world's smartest model. You may need to know how to combine available intelligence better than everyone else. That is a different kind of competition. At the same time, there's a limit to this idea, and Microsoft's approach still depends on stronger base models existing. Because if underlying models stop improving, the system eventually hits a ceiling too. You can coordinate forever, but eventually the workers themselves need to become stronger. So maybe the future is not one path replacing the other. Maybe both paths matter. Stronger models, smarter systems, working together. And honestly, that might be the biggest lesson from all of this. The future of AI might not belong to the biggest brain. It might belong to the best team. And if that idea scales, this could end up being remembered as one of those moments where the direction quietly changed. That's it for this one. Do you think Microsoft just showed the next stage of cybersecurity? Or are we watching the beginning of a much bigger shift in how AI itself gets built? I'd love to hear what you think, and I'll catch you in the next one.